Hi and welcome. So this time around I have another project for the laser welding company I do some projects for, and this is modifying one of their tools. The tool itself is called a seam welder. So this is the base plate for the seam welder, and it is dovetailed in shape, and this is actually the bottom of it. So it sits this way and the weld goes across here, and you can see where the laser damages a little bit of the copper cutting through the material, splattering. There's some very fine holes there, and what happens is argon is injected in here, which is flat up against the base of the mandrel that holds the welding plate. Some fingers come down and hold the part down, and then argon leaks out of these tiny little holes here. Well, for the project we're working on, they want to do some seam welding on some cans, and they need a deeper groove. So right now they have like a 60 thousandths groove that's 60 thousandths deep, and it keeps clogging with weld debris, and they have to stop and keep cleaning it out. So what they want to do is make a couple removable sections out of aluminum that are 1/8 inch wide, 1/8 inch deep, so they can collect more debris before they're unusable, and then make them swappable, so make a bunch of interchangeable parts. We also need to make a stop. So the part that holds the copper piece that the laser welder goes across is shaped like this, and you can replace these mandrels. Now I've drawn that straight. It's actually dovetailed with 10-degree angles. This piece here is going to be for a work stop that slides over this piece underneath that this slides into, so that they can move their work in and hit the same stop point every time, because right now they're just having to estimate and remeasure. Slows things way down. They're trying to automate this process a lot. Then we're going to make some of these pieces out of aluminum, and the goal there will be to have 11-inch sections where they can just slide their part on top of that 11-inch section, stop on this piece, and then weld it. And when the part gets filled up, they may throw it away, or they may try and clean it, and then slide another one of these pieces in rather than remake this whole very expensive copper piece. To do the 10-degree angle on here, I'm going to make some vice jaws that hold part at 10 degrees, so I only have to shift my head once, because they say that this will be a repeat project, and they'll want more of these parts made depending on what they're doing. So I'm going to make vice jaws that hold parts at 10 degrees. In order to do that, let's head over to the saw here. And a while ago, I bought this piece of stock that is 1 inch by 2 inch, and I'm using it for making vice jaws. And these are going to be longer than normal Kurt vice jaws, so I'm going to cut off a 1 foot section on the end. The part's 11 inches, I believe, but I'm just going to do 1 foot even. And we're going to start and just cut these guys off and make some custom vice jaws in a minute. The first part we're making today after I cut those off, however, is going to be the stop in the lathe, because I think I can complete that in one go. I've got this guy in my 4-jaw chuck because that was the easiest one to put a part this large in without having to reverse jaws. My other chucks, I would have definitely had to reverse jaws to fit this part. So I was being lazy, and ends up taking just as much time because you have to center it. But what we're going to do is face this guy first. This was supposed to be cold rolled, but the way it's cutting, I'm thinking it's stainless. Facing side number 2. Alrighty, in the end here, we have a Morse taper to threaded portion, and on that we're putting our 3/4 adapter for an annular cutter, and we're going to do 2-inch annular cut. I've never done anything this big, this deep, but we're going to try it today because I want to save myself some time and, you know, end up with a little piece of material that'd be useful when I'm done. So we'll see how that works out. I made this annular cutter adapter myself, but it's just 3/4 of an inch. So, okay, we're in there. Now we need to slow things down a whole lot, and we need to use some lube. See if we can add lube as we go. Of course, I'm collecting chips like a mother. That was not a good sign. Let's see what happened. I think cutting stainless might have been a little bit much for it. Too much force on it. So the cutter's completely fine. Still looking really good and sharp. But looks like I aced my threads off of my MT adapter. That was unfortunate. Let's see if we can get this out of here and take a look. So interesting, what happened was my adapter actually worked out fine. This Morse taper 4 to threaded part on the end, I thought the threads were cut into the end of a solid piece. That piece is press fit inside here and it is broken loose and now I can't get it out. Oh, well, you buy inexpensive stuff. This is, you can tell, made in China. I thought the quality was pretty decent. Actually fit the board, the Morse taper board, really nicely. So they did a good job on grinding. They just didn't do a good job with the threads, or what I've tried to do exceeds its capabilities. Correction, it was a solid piece and it snapped the threads off. That's pretty impressive. Apparently what I need to do is bore and thread this guy up to the 5/8 16 thread version I have here. The other one's not weak, not strong enough. This one would definitely be a lot beefier. The only problem is I have 5/8 18 but not 5/8 16 tapped, which means I'd have to thread this. I don't have time to do that. So moving on, next choice. So since I don't have that tap, I have another 3/8 24 adapter. Actually I have two more because I bought spares. So I'm just going to go lighter. I was pushing pretty hard. So hopefully we can do this without damaging it again. By the way, the hole I'm boring right now is 2 inches, if I forgot to say. And this is 304 stainless, I'm guessing. Someone dumped it in the cold roll section because that's all I really needed, but and we are through. It didn't go too badly, actually, after I realized I couldn't push it as much as I usually do. And we got a nice slug down the middle that'll be reusable. Good use of leather. Grabbing a very sharp cutter. Oops. That's nice, it fell out of there. I was worried I was going to have to pry it out. Cutter actually doesn't look worse for wear. Oh, one of these edges got a little warm. Just, oh, two on opposite sides, kind of weird. Performed well though, other than that. And you're left with a pretty nice slug that's really hot. Yikes. So we're at 2 inches, we've got a ways to go. 2.379. I'm gonna try a 50 thousandths pass here. It's actually breaking chips. Here's one of the parts to be welded, and it gets pressed together, and then the seam weld goes up the middle here. There are tabs on the end because when you're starting a laser weld, you don't want to start in the material or you might end up with a little hole there. So they put tabs on the end, so you start on the tab and the hole will appear on the tab, and you also end on a tab, and then you remove the tabs after the fact. That way you end up with a hermetically sealed container. Here is a finished example of a laser seam weld, and I don't believe they add any extra material in this, but I'm not certain. Pretty impressive weld, pretty amazing. All right, so the next step for this guy is we're going to cut off the top of this. because we're trying to make a stop that'll slide over the circular part, this round part here. But it doesn't, you can't go over the top because that's where the copper piece is and the aluminum pieces we're going to make are going to go. So the stop is only going to go up as high as where this cutoff point is here, and that's 3.2 inches. So I need to cut off at 3.2 inches. I need to cut this guy off, and I'm going to try and do it in the bandsaw, but I'm not quite sure how I'm going to hold this yet, so I'm still working on that part out. In order to maintain proper orientation, I think I'm going to hold the part in a vise. So I'm going to use this vise to do it. And what I think I'm going to do is I am going to set my zero, set my other zero. Then I want to go up 3.2 inches. When I clamp this guy in here with this on the base, that should be the point where I want to cut this guy off. Here's a sanity check just to make sure I'm not crazy, because I don't want to cut this and ruin that part. So there's 3.2. We're going to scribe the line. Pop this guy in the bandsaw and was able to clamp it and align it using a square. And I think we're just going to try and cut the whole thing. This would be the equivalent of cutting like almost a 3.5 inch thick piece of solid stainless, which is kind of significant, so it'll go slowly, but it should be straightforward. Got the part clamped down, lined up. Come up here to my handy dandy sheet that came with the saw. 304 stainless, 80 to 120 surface feet per minute. Got it at about 120, oops, that's 130, 120 surface feet per minute. It's going to take forever, but we'll get through. Two minutes in. We're about 1/8 of an inch into the part. It is slow but steady. That Morse taper 4 to 3/8 24 threaded adapter I had, well, I drilled it out and tapped it to 3/8 16 internally. It actually went pretty nicely, so it's not a complete waste, especially since the taper is so nice on this guy. It really engages well. It's been about 35 minutes and we're almost there. Absolutely crazy the amount of time it took. I could have just milled this off much quicker. I thought the bandsaw would be faster. I may not have the tension right, or the pushing force on the blade, so that's adjusted with that counterweight on the side there. And I did slide it down, but maybe not far enough. There we are with the surface finish. Surprisingly good for the bandsaw. It went very slowly. I think I needed to use a fewer tooth per inch cutter so that the gullets, because I think the gullets were kind of filling up, but it did a really nice job. Next up, to finish this guy off, we've got to take a little more material off of here, just a tiny bit. We're right at the line, which the saw cut was amazingly close to the line, but it's still got like maybe a 1/16 of an inch or 60 thousandths left to go. So we're going to take off some material there, and then we're going to drill and tap for these set screws. That's 3/8 16. And one thing I'll point out is their location is not at all critical, so that's not a big deal. It'll be quick and easy, hopefully. And then this part will be done. Except we got to test it on the machine because I don't have the machine here to test fit it. And I took very rough measurements while I was there because I didn't have the proper tools. So hopefully we'll be all right. To set the part up, just ran a square over the top of it and made sure both sides were approximately equal by eyeball. It's not a precision operation. This is a stop. And that part, the top part, matters not even a little bit. I think we have at least 60 thousandths to come off. Not that it's a specific amount actually, but I think we're going to shoot for a 25 thousandths pass. I'm going to call that good, and I'm going to take an end mill and take off the sharp edges here because they're not adding any strength anyways. You can see here how stainless sort of smears. This was the burr on the edge. The important thing is that the gap needs to be big enough for this to fit all the way through so that it can sit anywhere it's going to sit. It's going to be somewhere like around here. So that should be perfect. I'll deburr this and then we're going to drill and tap. Next up for the drilling, I've got this sitting on a parallel, lying flat, and just running a square up to it to make sure it's square. And then we're going to drill and tap. We'll make it symmetrical. And I don't need threads the whole way, so I think I'm going to countersink this down 1/4 of an inch. Here's one done. We're using brass tipped so that I don't damage the rod that it's going to push against. And I've still got to deburr the bottom, but we need to flip this over and drill and tap that side. To burr this guy, I use this tool that you stick in. I think I've showed this once before. And then you pop it like so, and then you can deburr the inside like so. Unfortunately, this one is right at the limit. The next size up is too big, and this size is just on the edge, so it's a lot of force, but it's working actually pretty well. Got the other side already. All right, so here we go. Part 1 done. Set screws, brass inserts. 2 are probably overkill because there's not a lot of pressure put on this. It's also really big and beefy so that it won't vibrate and move around. They want reasonable precision, so that's what we're aiming to give them.
1 day later, expectations crushed.
I took this over to the laser welding people and tried to fit this on. Even though I made this 5/1000 oversized, guess what? Doesn't fit. It's a little bit tight because there are some burrs and there's paint on the shaft that this needs to slide over. So I need to take about 20 thousandths off. So I'm trying to clamp this guy. I put the piece that I cut off back on, got it in the 4-jaw chuck, got it very tight this way, reasonably tight this way. Hopefully this will be adequate. So we're gonna try and get this guy going here. I need to measure the face here before we get started and run out in the face because I got it correct this way. Obviously I can't check this side because that's got a saw cut thickness missing, plus whatever I took off in the mill. I'm feeling a lot less comfortable about doing this. It's moving around a little too much. I've got the jaws reasonably tight. This is very thick material, but one, I might be deforming this and squeezing the ends together. I don't have it clamped that tight. These 2 across here I have clamped quite tight. But it seems to move strangely. So I think I'm going to take this over to the mill and bore it instead. All right, we moved to the mill where I think it's a bit safer. I still have to worry about this part getting pushed down. Got my Blake coaxial indicator in here, and I got this centered. Obviously I can't check this part here, but to within about 1/2 thousandth all the way around. This isn't critical, and I'm going to bore this out. Alrighty, I believe we're there. I think we're done. I'll take another couple measurements and then we can move on to the next part. We'll test this tomorrow.